Good evening. Today we are recording the solution video for electrochemistry chapter. Yeah. First question was related to the calculation of molar conductivity of solution. So resistance of solution was given when molarity was 0.2. The resistance was 50 ohms, whereas the specific conductivity of solution is 1.3. Okay. If the resistance of 0.4 molar solution is given as 260, we have to calculate what? Molar conductivity. Okay. So we know specific conductance is what? Cell constant upon resistance. So we can calculate the value of cell constant. Based on that, we can get specific conductance when resistance is 260. After that, with the help of the formula of molar conductivity, we can calculate the that is equals to K2 upon C. Remember here, we have to place concentration value while considering changing its unit. Means here the answers are given in meters square. Okay. So remember to convert volume from liter to meter cube and then substitute the value of concentration in the formula. Okay. So after calculation, you will get what? The answer will be, correct answer will be option C. Question number 2. The reduction potential of hydrogen half cell will be negative when? So see, reduction potential means what? Hydrogen will H plus will go to H2, or there will be reduction of hydrogen. Okay. So it will gain electron. H plus will gain electrons and H2 is released at reduction potential. Okay. Now E cell, we know E cell is what? E naught minus that equation for this half cell. Okay. This is RT upon NF. Okay. Ln K. For this reaction, we can easily see K value will be what? Pressure of H2 upon concentration of H plus square. Okay. And N factor here is 2 for this particular reaction where 2 electrons are transferred. To get that value negative, for hydrogen cell, we know that E naught value is 0. Okay. So to get E negative, what we can say? Pressure of hydrogen gas should be more than that of concentration of H plus. Okay. So for the given options, option A satisfies that condition. So answer will be option A. Question number 3. We are given with reduction potential of 3 metals: zinc, nickel, and Fe. Okay. And they are asking which will act as a they are asking which will get reduced and which will get oxidized. So here X is getting what? Oxidized, and Y is getting reduced, and which will support this change most effectively. They are asking that. Okay. So when we are considering X as zinc, see its reduction potential is what? Most negative, or what we can say, its reduction is its tendency to reduce is very low. Okay. So what it will try to be remain means zinc will convert into Zn2 plus, or it will oxidize itself. Okay. That metal is more reactive, we can consider that. Whereas the minimum value is for nickel, so it can be converted easily into what? It's metal. Okay. So it can be reduced. So Y should be nickel and X should be zinc. Question number 4. Again, some values are given. Reduction potentials are given to us, and we have to calculate, find out which will act as the strongest oxidizing agent. So maximum positive value. Oxidizing agent means what? Self reduction, and we are having the values of reduction potential. So whichever has the reduction value, reduction potential value, we can consider that as the strongest oxidizing agent. Here MnO4 minus has the highest reduction potential value. Okay. Question number 5. Here, question number 5, we are having E0 values for two half reactions. One is for silver, other is for tin. Okay. And we have to calculate EMF for the cell. Yeah. So what we can say, E0 cell will be equal to what? E0 oxidation plus E0 reduction. Okay. And after seeing the values here, we can easily see that silver will get reduced as its reduction potential is positive, whereas tin will get reduced as its reduction potential is negative. Okay. By adding that, we can calculate the value of E cell. So E cell is what? 0.94 volt. Option D is the correct answer. Question number 6. Resistance of solution is given for 0.2 molar solution. Specific conductance is given 1.4. Okay. Resistance of 0.5 molar solution is given 280. We have to calculate what? Molar conductivity of 0.5 molar solution. So it is similar to the question number 1, which we have solved earlier. Okay. We will calculate what? Cell constant first. Then with the help of that, we will calculate specific conductance. And after that, we can calculate molar conductivity of the solution with 0.5 molarity. Okay. Remember to convert the unit of concentration, where volume will be converted from liter to meter cube for this particular question. Question number 7. Standard reduction potentials are given for MnO4 minus, where Mn is in +7 oxidation state, and Cl2, okay, Br2 and I2. We have to check which of the following can get oxidized by MnO4 minus. Okay. MnO4 minus will act as an oxidizing agent. So we have to calculate first what we will do. We will calculate E value for, or E cell value, half cell value for Mn. Okay. MnO4 minus. So the half cell reaction is what? Mn plus 7 is getting reduced to Mn plus 2. And as you can see, the reaction is mentioned in front of you. Okay. Further, this reaction is happening when pH is what? 3. So what we can say, H plus concentration is around 10 to the power minus 3. Okay. Q for this reaction is given. That will be Mn plus 2 concentration upon MnO4 minus concentration into H plus concentration ki power 8. Remember that for this question, we can consider Mn plus 2 and MnO4 minus concentration similar, and Q can be represented by H plus concentration. After solving this question, we can obtain the value of E cell, which will be equal to 1.22 volt. And from the other E values of other components, like chlorine, bromine, halogens like chlorine, bromine, iodine, we can confirm that MnO4 minus will only reduce, oxidize Br2 and I2 to I minus and Cl minus. Okay. Question number 8. A variable position. Okay. A cell is applied to galvanic cell of zinc and copper. Okay. E cell of galvanic cell of zinc and copper is 1.1 volt. And the cell is applied, or battery is applied in the opposite direction. What will happen when external battery or potential is less than 1.1 volt? So we can say that the electron will flow as it is from a cathode to anode, and it will act as galvanic cell. But when the E external potential is greater than 1.1 volt, it will act as an electrolytic cell, and reverse reaction will take place. That is, electron will flow from cathode to anode. Question number 9. Here 2 Faraday of electricity is passed through a copper sulfate solution. So copper sulfate, copper will be deposited, okay, and Cu is in +2 oxidation state. So here transfer of 2 electrons are taking place. So to obtain 1 mole of copper sulfate, we will need 2 Faraday. Therefore, the amount of copper deposited will be equal to 63.5 gram. Question number 10. Yeah, a block of copper is dropped in zinc sulfate solution. Here we can easily see that zinc is more reactive than copper. So copper cannot displace zinc from its solution. Okay. Therefore, no change will be occurred. Question number 11. Yeah. Succinate ion is given, and its oxidation gives ethylene and carbon dioxide as product. Okay. This occurs at anode. Similarly, at cathode, what will happen? Water uh, will get converted into hydrogen gas, and or reduction reaction will occur there. Okay. Now, during this conversion, charge passed was equal to 0.2 Farad. From the transfer, we can see that each reaction requires 2 electron transfer. So what we can observe here is that for first reaction at anode, 2 moles of CO2 will be produced and 1 mole of ethylene will be produced when 2 Faraday charge is passed. So total 3 moles of gas will be released by 2 Faraday charge. Similarly, for reduction, we can see 1 moles of hydrogen gas will be released for 2 Faraday charge. Total gas released during the process will be 4 moles for 2 Faraday charge. But we are having 0.2 Faraday. So moles released, total moles of gas released will be equal to 0.4 moles. Okay. And by multiplying it by 22.4, we can get the gas in liters at standard condition. That will be equal to 8.96 liter. Question number 12. We are given with E0 values for chlorine, chromium, then chromate ion is there, and MnO4 minus ion is there. Okay, so we are having a reduction potential here, and they are asking us which will be the strongest reduction potential reducing agent. Okay, so when the E0 value is E reduction value is the lowest, that will have what the that will act as the strongest reducing agent. So from the above, what we can see, chromium will act as what? As a strongest reducing agent. Question number 13. We have to calculate E0 reduction for the conversion of Fe3 plus to Fe. See, whenever we are trying to add reactions, we can't directly add E0 values, but we know that delta G is additive in nature. We have a relation between E0 and EMF and delta G. That is delta G equals to minus NF E, say. Okay. With the help of that, what we can do? We can calculate delta G value for each reaction. And after that, we can add the reaction to get the required outcome. After the outcome is obtained, further we can convert that delta G into E naught for the final reaction. And doing that process, we can easily calculate the required answer. Okay. Here, by following that steps, the answer obtained is 0.056 volt, okay, minus 0.056. Option C is the correct answer. You can go with through the formula. Question number 14. Find the reduction potential of this. The following cell is constituted. Okay. The EMF of cell is found to be this much. The standard potential of half cell of this is here. See, what we have to calculate? We have to calculate the standard potential for M3 plus to M. Okay. We are having the value of E cell. So first we will calculate what E naught for the this process. And we can easily find out that E naught for this is equal to 0.481 volt. Okay. After you have calculated this value from the given reaction, we know that E naught cell will be equal to E naught oxidation plus E naught reduction. So here we have to calculate reduction potential for M metal, and we can easily calculate with the following relation. So we will subtract the reduction potential of silver from E naught cell, and we will obtain the oxidation potential of metal. By changing the sign, we can get the reduction potential of metal M. Okay, answer will be 0.32 volt. Option A. Question number 15. 9.65 ampere current is passed through for 1 hour, okay, in nitrobenzene in acidic medium. So the final product is what? Para-amino phenol. Okay. We have to calculate the number of transfer of electron during this process first. So here NO2 will be converted into what? NH2. And earlier nitrogen in NO2 was in +3 oxidation state. Later in NH2 it is in -3 oxidation state. Total there is what? Total gain of 6 electrons during this conversion. Similarly, if you can observe that the carbon on para position of NO2 is at -1 oxidation state, but after attachment of OH molecule, what we can say, it is at +1 oxidation state. Now here 2 electrons are lost during this process. Okay, so the overall molecule had gained 4 electrons during the change of the compound or during the reaction. Okay, so 4 Faraday current will be required to produce 1 mole of change for the compound. Okay, 1 Faraday will produce 1/4 moles of the product. Okay, whereas we are given with what? Charge, current, and for what time that current was passed. So we can calculate the amount of Faraday or charge we were having. So it was equal to 0.36 Faraday. Okay, so during that by that much current, we can obtain 9.81 gram of the conversion for the reaction. Question number 18, 16. Okay, yeah, here's E cell values are given. Sorry, we have to calculate E cell values with zinc. Okay, and different metals reduction potential are given. We have to calculate maximum value of E cell per electron. Okay, so you have to first calculate the E cell value, and you have to divide by it by the number of transfer of electron taking place during this conversion. For first, for gold, one, what we can say here, the E cell will be what? E cell will be 2.16, and after dividing it by 6 we can get a value. Okay, similarly for silver and zinc we will get 1.56 divided by 2. For Fe and zinc we will get 1.53 divided by 2, and for Fe2 plus 2 Fe we will get 0.32 divided by 3. Here in case B, what we can conclude here is that maximum E cell will be obtained per unit electron. So our silver cell will be considered, reduction cell will be considered for the